This is the first video where I'm going to talk about combinations and permutations. We're going to cover all the combinations here and then a touch of it in the third video. But basically, combinations are how many ways can you order a set of things or sets of things where order does not matter. Okay, so let's look at an example. Let's say that you're flipping a coin twice. And your first flip could be either heads or tails, right? And then your second flip can either be heads or tails. Heads or tails. So let's look at the distinct outcomes, the unique outcomes. First flip is heads, second flip is heads. It's 1. First flip is heads, second flip is tails. 2. First flip is tails, second flip is heads. 3. First flip tails, last flip tails, 4 outcomes. Those are all 4 of the ways that this can happen. Right? There's no other way this can happen. That's it. That captures every possible combination. So how do you get there math-wise without having to draw a big chart? Well, it's pretty straightforward. You just multiply it together. And you can think about it as multiplying the possibilities. In this case, it's sort of the sequential thing, right? Like first flip times second flip, right, is equal to total number of outcomes. But it doesn't have to be like that. In fact, it can kind of be the other way around. It can be one set of items times another set of items where you kind of pick maybe everything at the same time or really close. You'll notice that in that example, the coin flips, it's a lot like probability, right? In fact, if you were trying to pick a specific outcome, say tails and tails, it'd probably be 1 and 4. The outcome you want, or the outcomes you want, over all the possible outcomes. So combinations and permutations are typically considered to be a probability topic. In fact, on your graphing calculator, the factorial and the NPR and NCR show up in the probability menu. More on those other things later. Check out the video on distinct permutations and the video on selecting from a set for more on that. So let's look at the ACT example on the bottom of your screen. This is the classic combinations problem, most common combinations problem from time immemorial. Now, it's relatively straightforward. Now, the biggest thing to watch for is you make sure you get everything, so be very careful, write stuff down. Occasionally, they'll use words instead of numbers to try to get you to miss something. And so let's go through it item by item, break it into statements. Picks a pair of jeans from 6 pairs of jeans. Picks a shirt from 10 shirts. Pair of socks from 8 pairs of socks. And a pair of shoes from 4 pairs of shoes. And these are the different possibilities. Now you could actually draw a huge tree that represents that. But really, I can only wear 1 pair of jeans, I can only wear 1 shirt, I can only wear 1 pair of socks, and I can only wear 1 pair of shoes at a time. So those are the unique sort of sets. By multiplying them together, I can find how many total outfits I can make. That's really all there is to this. So 6 times 10 is 60, times 8 is 480, times 4 is 1920. Sorry, it took me a second on that. There's 1,920 possible combinations, 1,920 outfits. So in the next video, we're going to talk about permutations. That's where order matters, and distinct permutations. And those are increasingly important topics. Now, the standard permutation you've always kind of run into, but the distinct permutation and the selecting from a set have shown up more recently on the ACT. In fact, they're featured in the new Red Book. Make sure you take a look at those. Those are trickier topics, and you're less likely to be very comfortable with them.